This video, we're going to go through pages 79 and 80, which are segments formed by intersections inside a circle and then outside a circle. So in the last lesson, we talked about angles with these same pictures, but now we're talking about the lengths of the segments of the chords and the secants and the tangents. And so if two chords intersect inside the circle, then the product of the two lengths of one chord is equal to the product of the two lengths of the other chord. So what that means is that AE, so AE is this length times the other length of that chord, which would be EB or BE, is equal to the length DE, which is the small length of the other chord, times the length EC, which is the other part of that chord. And so I labeled them with lowercase variables just so you could see. So if I call this for segment A, so if I multiply A times B, notice they come from the same chord. So the two parts of the same chord times two parts of the other chord. So those would be D and C. Then those two quantities are equal. And so for these notes, again, just because it's the last one, we're going to go through and skip a little bit for the sake of time, just to get it to where you can understand enough for the problem set. So for example, we're going to do all of example one, A and B, example one on the front, and then on the inside, we're going to do a little bit skipping around. So if I'm finding the value of X, I'm taking a single chord and I'm finding the product of those two values. So 3 times X is equal to the product of the values on the other chord. So the other chord's numbers are 2 and 12. So that means that 3X is equal to 24. And so dividing by 3 tells us that X is 8. So we're looking at the diagram and we're taking the two values from one chord. So if I do the one with the variable first, that means I'm going to multiply 8 times X, and I'm going to set that equal to the values on the other chord, which are 2 and 6. That's equal to 2 times 6. So that means that 8X is equal to 12. And then dividing both sides by 8. If I divide 12 by 8, that gives me that X is 1.5. Okay, so structurally it's very easy when I have just a single variable. When there's multiple variables, that's when things can become more complicated. So we're going to not do example 2. We're going to do example 3 and then just A from example 4. So for example 3, we have a little bit more complicated of a situation going on because we have an X on each part. So that means that the algebra will be a little bit longer. So I'm still looking at taking one chord. So if I have X times 12, and setting that equal to the parts of the other chord, which in this case I have 6 times X plus 5, I'm going to have to distribute the X in order, or the 6, in order to simplify this appropriately. So that means that this is going to be equal to 6X plus 30 on the right, and then the left is just 12X. So if I have that 12X is equal to 6X plus 30, I want to get all the X's to one side. Since the left already only has X, we should subtract 6X from both sides. Doing so gives us the equation 6X equals 30. And then dividing both sides by 6 give us a value of X equals 5. And so notice that this problem is not asking us for that answer, it's asking us for AB. So AB is this whole length here. AB is X plus 5 plus 6. So if I plug in the value for X, that's 5, so 5 plus 5 plus 6 tells us that AB is 16. And then similarly, DE is this whole line. So I'm going to add those two pieces together. So DE is x plus 12. And so if x is 5, 5 plus 12 is going to give us a length of 16. So the length of DE, I'm sorry, 17. The length of DE is 17. Okay, so these last two are going to be a lot more complicated, and we'll see why in a second. So when I'm multiplying these things together, notice that every single piece has a variable. So if there's an x everywhere, that means that I'm probably going to end up with some x squareds. So if I look at one line, so if I'm looking at this line here, AB, the parts of AB are x plus 10 and x plus 1. So x plus 10 times x plus 1 is equal to the product of the parts of DE. So the parts of DE are x and x plus 13. So what makes this complicated is I have a binomial times a binomial, which is going to end up with a quadratic trinomial. So I'm going to end up with x squared and an x term, which means I'm going to end up with something that I'm going to have to factor. Okay, so remember that with this, we double distribute. You could also draw a box if you're more keen to that in terms of multiplying. So if I multiply x times x, I get x squared. Then I'm going to multiply that same x times the 1. So that's just going to give me plus 1x. Then I'm going to multiply the 10 times the x, so plus 10x. And I'm going to multiply the 10 times the 1, so plus 1. Then on the right side, I've just got a distribution. So I'm just multiplying x times x, so x squared, and x times 13, so plus 13x. So if I clean this up a little bit and combine like terms here that I stacked, I've got x squared plus 11x plus 1. Whoops, that was supposed to be a 10. 10 equals x squared plus 13x. So normally when I have a quadratic, I need to get it equal to 0. So what we'll notice though is that if I take and I subtract x squared from both sides of this equation, the x squareds go away. So that's good in terms of work because that means that I'm not going to have to factor anything. So what I want to do then is I want to work the same way that I did in the last problem, where I want to get all the x's to one side. So since 13x is over there by itself, I'm going to subtract 11x from both sides so that it moves this one over. So I got 10 is equal to 13 minus 11, so 2x. And then dividing by 2 tells us that x then is 5. 2. X is 5. Remember that this problem is asking us to find the length of AB and the length of DE. So AB is x plus 10 plus x plus 1. So that means we're doing 5 plus 10 plus 5 plus 1. And so that's going to give us a total length of 21. Next, we're going to look at DE. And so DE gives us x plus 13. So x plus 13 plus just an x. Okay, so since x again is 5, we're doing 5 plus 13 plus 5, and so that's going to give us a length of 23. AB is 21, DE is 23. Okay, so we're going to finish up with example 4. In example 4, we will have to factor some things. So looking at example 4, we don't have the circles labeled, but they are giving us some information about the pieces of the circle. So ER is 5, so let's label that with 5. And GR is 8. So those are 2 parts of the same line, so that's nice. They're both numbers. We aren't going to have anything crazy. But then they give us FH. Notice FH is this whole entire line. So that whole line is 14. So what has to happen here is we need to use a variable to create these parts. So since the problem is looking for FR, so since our final answer is going to be what is FR equal to, I'm going to call FR X. So if I label FR as X, and I know that the whole length is 14, that means that then this side from R to H is 14 minus that X. Okay, so if that was 6, right, I would know that the other one had to be 8. So that's the idea here, is if I know that X is 6, the total has to be 14. So 14 minus 6 gives me 8, and that tells me the 2 pieces. Okay, so I have to set that up in that way in order to get to my answer. So we're looking at product of the 2 parts of the same chord. So 5 times 8 is equal to X times 14 minus X. So on the left side, we're just multiplying. So 5 times 8 is 40. And then if I distribute, I get 14x minus x squared. So in this case, if I move the x squared, I will not get the x squared to disappear. What I do have to do is I need this to be in the form ax squared plus bx plus c equals 0 so that I can factor it. What that means is that a must be a positive number. Right now, the number in front of x squared is negative. So what I want to do is I want to add x squared to both sides and move everything to the left so that I can factor. That means I also want to subtract 14x. Sides of my equal sign. What I end up with then is x squared minus 14x plus 40 equals 0. So that's in my standard form. Ax squared plus bx plus c is equal to 0. From there, I have to do the product sum. So remember that to find the product, I'm looking at, I'm try to color code here, a times c. So 1 times 40 is the number 40. And then my sum needs to be b, which is negative 14. So what I'm doing is I'm looking at numbers that multiply to 40. So for example, 1 times 40, whoops. 2 times 20, 4 times 10, and so on. And I want to find the ones that add to negative 14. So since it's multiplying to a positive and adding to a negative, they both need to be negative. So notice that that's going to give me 41. That one doesn't work. This one's going to give me negative 22. This one, though, is going to give me the right values. So remember that what this means is that this factors to x minus 4 times x minus 10 is equal to 0. I'm going to move this FR over because we're not quite there yet. So now what happens is I get my answers. So remember that if x minus 4 is equal to 0, that means x is positive 4 or x is positive 10. Since we called x FR on purpose, that means that those are my two answers. So it's either 4 or 10 are the answers to this one. Okay, so when I have to factor, I can get two answers. If one of those was a negative number, I would eliminate it. Okay, so any positive answer is okay. A negative is not though, because remember this represents the length of a line. So the length of a line can never be a negative value. So let's look at one more just to kind of practice this factoring technique, because I don't think we have any factoring ones on the other page. Okay, so if I'm looking at this diagram, HR is 12. So HR is this guy here is 12. HF is the whole piece here. So this whole piece is 20. And so if I think about that, if that is 20, then 20 minus 12 is going to give me 8. So that means that this guy here is 8. Okay. Okay, so I know the whole thing's 20. I know one piece is 12. That means the remaining piece is 8. EG is also given to us. EG is the whole other piece. I'm going to write that number there. So that one's 22. This one's going to work just like the last one did, where if I want to find ER, that's what I'm going to name X, which means that 22 minus X is the other part of that chord. Okay, so now that we know each piece of the chords, we can set up our equation to solve. So we know that 8 times 12 must be equal to X times 22 minus X. So if I multiply this through, 8 times 12 is going to give us 96. That is equal to 22x minus x squared. So the process for this is going to follow exactly the same as what we did in the last one, where we're going to need to move everything to the left because this x squared is negative. So we always have to have a positive x squared in order to factor. So we're going to add x squared, and at the same time we're going to subtract 22x just to move all the pieces over to the left to get 0 on one side. So again, it had to be the left because we needed x squared to stay positive. So we have x squared plus 22x plus 96 is equal to 0. So when we find our product sum, we're taking A times C, so 96, and we need two numbers that multiply to 96 and add to 22. Since both of these are positive, that means that positive numbers will work with our answer. So remember that when we're factoring, we're thinking about all the factors. So 1 and 96. Oh wait, I messed up. It's not positive 22. That says minus 22 here, but I wrote plus here. So this would be x squared minus 22x. So it's a negative 22 here. So I was wrong. Both of these are negative again in order for us to get that negative 22. So that's not going to be anywhere near 22. So then if we keep kind of going through, so then 96 divided by 2 gives us 48. So negative 2, negative 48 is not going to work. Negative 3, negative 32 is not going to work. -4, and then -24 is not going to work. But -6 and -16 does. So -6 times -16 makes +96, and then those two numbers add to -22. So that means our factors are x minus 6 times x minus 16 is equal to 0. And so that gives us two values for x again, because this one's going to be +6, and this one's going to be +16. Okay, so because we made ERX, means that those are just our answers. So ER is either 6 or 16. Again, if one of those answers was negative, we would eliminate it. It would not be an appropriate answer to represent the length of a line. Okay, so those are when the lines intersect inside the circle. Page 80 is going to have us look at when they're intersecting outside the circle, so the kind of ice cream cone looking problems. So if I have two secant segments that share an endpoint outside the circle, the product of one secant segment, so the whole secant, and its outside segment is equal to the product of the other secant segment and its external portion. So in this problem, if I have AC is the whole, then I'm going to multiply that times the outside. So the outside for this one is BC. Okay, so then for the other segment, I have the whole line, EC, and I'm going to multiply that times the outside of the line, which is CD. So that is the secant theorem. So whole times outside equals whole times outside for these problems. Okay, so if I look at the first line, so if I take this guy, the whole thing is just the sum of the two, right? So if I find the whole, I'm doing x plus 3, and that's going to give me the length of the whole. So x plus 3 times the outside is the 3. If I look at the other one, the whole is 10 plus 2, so 12, times the outside is 2. Okay, so if I need to simplify this, I have to distribute. It's always easier to distribute the single number into the binomial. So my constant times my binomial gives me 3x plus 9 is equal to 24. So then to solve this, I have to subtract 9 from both sides. So 3x is equal to 15. And then divide both sides by 3. So that x is 5. So again, I'm looking at the whole. So in this case, 3 plus 5, a whole of 8, times the outside 5 is equal to the whole x plus 4, which I can't simplify, times the outside 4. So 8 times 5 gives us 40 is equal to 4x plus 16. So then to get x by itself, we're going to subtract 16 from both sides. So that means that 24 is equal to 4x. And dividing by 4 will give us our answer. That x is 6. So whole times the outside is our product for the secant segment. Okay, so we're going to look then, we're going to skip C and then go to example 2, just to do something where we have to plug in. And so our whole for this one is x plus 3 plus 8, which means we've got x plus 11. So we're going to do x plus 11 times 8. And that must be equal to, we've got x minus 3 plus 10. So that's x plus 7. So whole is x plus 7 times the outside is 10. So in this one, we do have to distribute twice. So if I distribute the 8, 8x plus 88 is equal to 10x plus 70. So since there's an x on both sides, we're going to need to move the variables to one side and the constants to the other. So since 8 and 10 is larger, let's subtract 8x from both sides to keep things positive. And then since we're moving the 8 from the left, we want to move the 70 from the right so that our constants are only on the right side. On the left side, sorry. Okay, so 88 minus 70 is going to give us 18. And 10x minus 8x is 2x. So 2x equals 18, and we divide both sides by 2. That allows us that x is 9. Okay, so the question is asking us for RT, which is this whole purple. So RT is x plus 11. And then we just found that x is 9. So that means that RT is 20. And then the other one they're asking us for is TV. TV is the line that we added together and used orange here. So TV is x plus 7. And so since x is 9, that's going to give us a value of 16. So our two answers are 20 and 16. So that's two secants. In the next problem, we're going to look at a secant with a tangent. So if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the length of the secant segment and its external portion, so the same thing that we were doing with the secant, is equal to the square of the length of the tangent. So that means that if I'm doing AC, so AC is the whole secant times the outside part of the secant, which is BC. That would be equal to the tangent squared. The tangent is CD. Really, you could think about it using the same formula as we did with the secant, because the whole tangent is all outside the circle. So you could still use the idea of whole and outside. It's just that those two values are the same. That's why it ends up squared. Okay, so we're just going to look at example 3, A, B, and C, and then that's all that we'll do for this one, so that you can work on the assignment. Because remember that this assignment is due this Friday, because grades are due at the beginning of next week. So for this one, we're looking at the secant. So the secant line is this guy. If I add, ooh, that's ugly. If I add this together, 18 plus 6, that means that the whole length is 24. So that means that I'm going to do 24 times my outside 6 is equal to x squared. Okay, so then 24 times 6 actually gives us 144. And so when I take the square root of this, normally when we take a square root, we write plus or minus. But remember that because this is the length of a line, I'm not going to use negative 12 as my answer. So it cannot be negative 12. It can only be positive 12 because it's the length. So I'm not writing plus or minus if I take a square root. Okay, so then for B, we are looking at our secant first. So our secant is this line, which means that I'm just adding x plus 5 to find the whole. So the whole line is x plus 5 times the outside is 5. And that's equal to the tangent line squared. So 10 squared. If I distribute the 5, I get 5x plus 25 is equal to 10 squared is 100. So then I just have one x on the left side, which means I want to move the 25 over so that I can solve. So if I subtract 25 from both sides, that gives me 5x equals 75. And then dividing both sides by 5 gives me that x is 15. Okay, so then for the last two, we've got a whole length already shown for us for the secant, so we don't have to do any adding. Everything we need is here. So we're doing the 9 times the x, so the whole times the outside is equal to the tangent squared. So 9x is equal to 36. So dividing by 9 tells us that x must be 4. So then for our last one, if we look at the whole here, that's 4x plus x. So that's going to be 5x. So 5x times the outside x is equal to the tangent line squared. Our tangent line is 20. So that means that 5x squared is equal to 400 because 20 squared is 400. So then we have to divide both sides by 5. So that x squared is equal to 80. And then if we take the square root of this, 80 is not a perfect square. So 81 we know is 9, its square root. So I know this is going to be close to 9. So you are going to have to use your calculator for this. So if I take the square root of 80, I get about 8.9. Okay, so secant, I always do the whole times the outside, so I might have to add things together. And then for a tangent, it's always just that value squared because the tangent is the same whole and outside. Okay, so those are the three different theorems for segment lengths when I have these intersections inside and outside of a circle.